Hi, this is Aksa. I'm a PhD student at CMU and I'm going to present my work on analyzing third-party dependencies in modern web services. This is a collaborative work with my advisors, Vyas Sekar and Yuvraj Agarwal. The study is motivated by the 2016 DDoS attack that happened on a third-party DNS provider named Dyn. During this attack in 2016, a lot of popular websites such as GitHub, Spotify, and Twitter were inaccessible to many users for many hours. In fact, the list of websites that went down goes on. It includes almost all the popular web services we know. So how were the attackers able to bring all of these down together? This was possible because all these websites, such as Netflix, exclusively relied on Dyn as their authoritative name server. As a result, when Dyn was DDoSed, a lot of websites were inaccessible to millions of users. Here is an outage map of the attack. In total, 178,000 domains were offline and tens of millions of users were affected. Attacks like these raise many questions about the resilience of the internet. How easy is it to bring down the internet? Particularly, we need to understand how prevalent these kind of third-party dependencies are. For example, how many other websites are at risk of Dyn-like attacks? Secondly, are there any other hidden dependencies that we need to know about? There might be inter-service dependencies which indirectly affect websites. For example, a DNS provider which is being used by another CDN provider. And finally, since Dyn attack had such a huge impact, it is natural to think that websites would adopt as a result. How has the world changed in using third-party services as a consequence of the Dyn attack? For example, did websites stop using Dyn, or did they start using multiple DNS providers? To answer these questions, we analyzed top 100,000 Alexa websites. Alexa is an external service that ranks websites by popularity. Alexa rank is calculated from a combination of daily visitors and page views on a website. To see how the world changed in response to the Dyn attack, we look at the dependencies of top 100,000 websites in 2016 and in 2020. To answer these questions, we first need to identify services which are crucial for users' access to websites. To do this, we look at the life cycle of a web request. When a user makes a request to a website, it first goes to the authoritative name server, which provides the IP resolution of the website. After the IP resolution of the website, user starts a TCP handshake followed by an SSL handshake if the website supports HTTPS. If yes, the website provides a certificate which is verified for revocation by the user by contacting the OCSP servers or CRL distribution points set up by certificate authorities. Finally, if the certificate is valid, the user requests the content on the website page. If the website is using a CDN, then CDN will serve the content. Based on this, we identify three services. The first one is domain name system or DNS. The second one is certificate validation by CA, and the third is content delivery network or CDNs. Given these services, we need to identify what exactly we want to measure. We are interested in third-party dependency of a website. For example, here, a website TechRadar uses another entity, Let's Encrypt, as its certificate authority, hence TechRadar has a third-party dependency on Let's Encrypt. There might be indirect dependencies between websites and service providers. For example, here, Let's Encrypt uses Cloudflare as its authoritative DNS provider. Hence, TechRadar has an indirect dependency on Cloudflare. We are also interested in critical dependencies, which exists if a service provider is integral for a given service. For example, here, if Cloudflare is down, OCSP servers of Let's Encrypt will also not be accessible. Hence, Let's Encrypt has a critical dependency on Cloudflare. In case of DNS and CDN, we compute critical dependency by measuring if the website is redundantly provisioned or not. And in case of OCSP, we do this by seeing if the website supports OCSP stapling. For instance, here TechRadar does not support OCSP stapling, hence TechRadar has a critical dependency on Let's Encrypt. Now, given this context, we are interested in knowing how prevalent third-party dependencies are and how concentrated different third-party providers are. Overall, we found that 89.2% of the top 100,000 websites use third-party DNS, 32.2% use a third-party CDN, and 76.8% use a third-party CA. Moreover, 85% critically depend on a third-party DNS provider and 28% critically depend on a CDN provider. That is, they're using a single third-party DNS or CDN provider. We also found that 59.5% critically depend on a CA. That is, they do not support OCSP stapling. All in all, we found that 89% of the top 100,000 websites critically depend on either a DNS, CDN, or CA provider. In addition to this, we also found that critical dependencies are higher for less popular websites. For example, we observed that 49% use a third-party DNS provider in the top 100 websites and 89% in the top 100,000. Same is the case for critical dependencies. This means that more popular websites care more about availability. Now, since third-party dependencies are very prevalent, it raises the question of how concentrated various providers are. The greater the concentration, greater will be the single points of failure. This is a dependency graph where each edge shows the dependency of a website on a third-party DNS provider. The size of each node is proportional to its in degree, which in the case of DNS provider is the number of websites using it. We observed that the topmost DNS provider, Cloudflare alone, serves 23% of the top 100,000 websites. In general, we observed that only top three serve almost 40% of the websites when the total DNS we found in our data were 10,000. This indicates that the DNS space is highly concentrated. We see similar trends in CDN, where the topmost CDN provider, Amazon CloudFront, alone serves 26% of the websites that use CDN. Particularly, we observed that only 3 CDNs serve almost 60% of the websites that use CDN. Now the question is, if this is the complete picture, or do we need to take indirect dependencies into account as well? This brings us to our second question, which is, are there any indirect dependencies between websites and their third-party providers? To do this, we first need to analyze inter-service dependencies between DNS, CDN, and CA providers. Let's look at inter-service third-party dependency. In case of CA to DNS dependency, we found that out of the 59 CAs that we observed, 48% of them use a third-party DNS provider. In case of CA to CDN dependency, 36% use a third-party CDN provider. Moreover, out of the 86 CDNs that we observed, we found that 36% use a third-party DNS provider. Hence, third-party dependencies are also prevalent among service providers. Now let's look at the critical dependencies of service providers. In case of critical dependencies, we found that 31% of the CAs relied on a single third-party DNS provider, 36% relied on a single third-party CDN provider. Similarly, 17% CDNs relied on a single third-party DNS provider. These critical dependencies between service providers actually give rise to indirect dependencies between websites and service providers. But why do we need to care about indirect dependencies? In this graph, we are showing website to DNS dependency and website to DNS, including CA to DNS dependency, and we show the top 5 DNS providers. As a result of indirect dependency, we see huge amplification in the impact of a given provider. For example, in case of CA to DNS dependency, Cloudflare now critically serves 37% of the top 100,000 websites, as compared to 24% before. In case of DNS made easy, the impact goes from 1% to 23%. Now, given this picture of third-party dependencies in 2020, let us look at how the world changed after the Dyn incident. Did websites try to reduce their third-party dependency? Did the concentration among providers decrease? Let's look at the change in critical dependency of websites. We observed that critical dependency in DNS increased by 4.7%, while we observed no significant change in CDN and CA dependency. Overall, we do not see any significant change in critical dependency of websites. Let's see if we see the same trend in inter-service dependencies. With respect to inter-service critical dependency, we observe an 8% decrease in critical dependency in CA to DNS dependency and a 4% decrease in CDN to DNS dependency. This is encouraging because this means that overall inter-service critical dependency decreased. Now let's look at what happened to the concentration of service providers. According to this figure, in 2016, 2,700 DNS providers served 80% of the websites, while in 2020, only 54 providers serve 80% of the websites. This is not an encouraging result because it means that single points of failures got bigger in DNS and CA providers, while we observe that the concentration decreased in CDN providers. To summarize our limitations, our measurements are from a single vantage point, hence we may miss region-specific dependencies. We analyze dependencies on landing page of a website only, so we might miss dependency that manifests deeper in the content hierarchy. We also do not look at physical and network infrastructure dependencies such as routing and hosting. In the light of our observations, we have the following recommendations. Websites should consider redundancy while using a third-party provider. In fact, during the Dyn attack, we observed that those websites which were redundantly provisioned were not affected by the Dyn outage. Websites should also try to understand their indirect dependencies. For instance, when the Dyn attack happened, the websites that used Fastly were also affected because Fastly used Dyn as its authoritative name server. With respect to service providers, they should make it easy for websites to be redundantly provisioned. For instance, in our paper, we discovered that many providers do not support redundancy, while many do, for instance, Dyn and NS1, but other providers like Cloudflare or Amazon Route 53 do not allow that. Hence, service providers should support and encourage redundancy. They should also be careful about their own inter-service dependencies. That is, if they are using other third-party service providers, they should try to be redundantly provisioned. And they should also be transparent about their inter-service dependencies. Finally, service providers should be more transparent about attacks that happen on their infrastructure. To summarize, the DDoS attack on Dyn in 2016 raised some questions about the resilience of the internet. In our paper, we try to answer some of these questions, particularly about the prevalence of third-party dependencies and their impact. To do so, we analyze top 100,000 popular websites. We also look at the inter-service dependencies to get a holistic view and identify the potential single points of failure in the internet. Our key findings include, with respect to the prevalence of third-party dependency, we observed that 89% of the top 100,000 websites critically depend on either a third-party DNS, CDN, or CA provider. We also found that an attack on a single provider can take down almost 30% of the websites. With respect to impact on indirect dependencies, we found that indirect dependencies significantly amplify a provider's impact, in some cases by as much as 23 times. With respect to what changed after the Dyn incident, how did the websites adapt? We see no significant change in website dependency. However, we do see an encouraging decrease in inter-service critical dependencies by up to 8%. Our code is also available online. Thank you.